Greetings, my name is Pete Ring. My background is in military aviation and in particular fighters and choppers. I do these chats on behalf of Air Force Association New South Wales and on behalf of Wings magazine and also for our Wings Australia YouTube channel. Could I also ask that if you like our videos then please subscribe to our channel and have a look at the description on our channel for this video, and you'll find links to subscribing to our magazine called Wings and subscribing to Air Force Association New South Wales. I'd like to welcome Ron Haack. Ron, I'm looking forward to hearing about the part of your life was where you flew as a test pilot. Now, the only question I want to open with is that when you say test pilot, sometimes it sort of there's a phrase bandied around that a lot of people believe indicates danger and courage. So my first question is, what is a test pilot?
Well, that's actually quite a good question, Ringo, but essentially test pilots have been specifically trained through a course. There's a number of courses around the world. I was trained in the UK at the Empire Test Pilot School. And in those days, the schools were teaching people to be what I'd call experimental test pilots. So I'm formally acknowledged as an experimental test pilot, but I need to go and explain a wee bit about the test flying game. And in fact, it applies to any sort of testing environment, really. But there are basically four categories of testing, if you like. The top level is experimental, and that's really designed to prove a concept. The next level is developmental, and that's designed to prove a design. And the next level is operational, which is really about proving mission worthiness or capability. And then there's a fourth level, which is called production maintenance test flying, which is basically about demonstrating build standard. So in other words, making sure a machine comes out of the factory built to design, which has already been proven by developmental testing. Okay. Or comes out of maintenance, heavy maintenance, and is operational. It works fine.
So we'll dig into those in a minute. But what was your main flying that led up the time where you were sent for test pilot training? What did you mean flying?
Well, typically in the RAF, we looked for mostly fighter pilots.
So is that what you were?
Sorry?
Is that what you were?
Correct, I was. Okay. I'd spent 4 years in the operational world flying Mirage 3.
Yeah.
2.5 years in Malaysia and about 18 months or 6 months, I think it was, in 77 Squadron back at Williamtown.
Yeah.
And was selected to go to test pilot school. So at that stage, I probably had, about 1,200 hours in Mirage. I'd flown DC-3s prior to that, and I had about 1,200 hours DC-3 time. So I had a bit of a broad range of experience in some respects. So a bit of twin engine transport time, as well as a lot of single engine fighter time.
So that was when you went to test pilot course, you'd been flying the Mirage?
Yes, I had.
Okay.
Yeah. And in those days, before we went to test pilot course, the RAF put us through a bit of a preliminary exposure. So I went off and got a Canberra bomber conversion. Did some Nomad flying at Ardu, did a wee bit of Mackie flying, and I can't remember what else. There's probably something else in there as well. But anyway, that was all sort of preliminary to see whether we had the aptitude or whether the whole sort of speciality would appeal to us.
Now, how long was test pilot training?
All up about a year calendar-wise, but the course itself was 10 months, 10 to 11 months. And it's an exciting time in your life because you're pretty young, pretty green, wet behind the ears. And I seem to recall, and I was going to check on this before, but in the first 2 to 3 weeks in UK, they check you out on 5 different types. And you go solo on each of these aeroplanes. You've never flown them before, of course. And the checkout was fairly rudimentary. First flight was a familiarization ride. The second flight was an instrument rating test under a hood, and the third flight was solo. So it was all pretty advanced, well, not advanced, but accelerated.
So what was the first aeroplane on the test pilots course that you did that out of the five? What was the first one?
Oh, the first one was probably the jet provost, and they sort of lead you into this stuff, of
What's
course.
that do? What's that do for a living?
It's a trainer, a bit like the Mackie, except it's side-by-side seating.
So a jet trainer.
Yeah, trainer.
Yeah.
And then
What
from there,
what was next?
probably the Hunter, single-seat Hunter.
That was a 50s fighter, was it?
Yeah, 50s, 60s fighter, yep.
Yeah. What was next?
Canberra bomber, but I'd already been qualified in the Canberra,
Yeah.
but they checked me out anyway. And then the Andover, which is a HS 748. So twin
Which is what, a
turbine,
twin engine?
yeah, twin engine turbine, light transport. And the Andover, the only difference between the Andover and HS 748 was that it had a kneeling undercarriage. So it actually lower the fuselage down closer to the ground to load things through the ramp. In the meantime, in the same time, we're doing ground school, heavy mathematics and physics, and touching on aerodynamics, of course, all the physics and maths orientate around aerodynamics and structures. And so we're doing that while we're doing this flying as well. So it's pretty intense in terms of the amount of mental effort involved in just learning about the aeroplane. And the other thing they teach you, the whole idea of all this stuff is to try and make you more comfortable jumping from into different airplanes. So
Yeah.
when you were to get involved in experimental flying, you'd be flying airplanes never been flown before, and you have to feel pretty comfortable and know what you're doing. And you actually develop some routines about what things in the cockpit are really important. When you're flying operationally in a squadron, you go through a lot of checks, but a lot of them are administrative checks. They're not important. They're really just to make sure you get the aeroplane set up to go ahead and do the job you're going to do. But in test flying, you realise there's only about 4 or 5 checks that are important. And the same with emergencies. There's only a couple that require quick action memory items. Most of the rest you can do in fairly loose time, if you like.
Well, that presumes you've had some experience flying. You wouldn't want a novice doing that, would you?
No, of course not. You need to have a bit of experience to be able to actually handle, comprehend what's important and what's not important. Yeah.
So that was in the days before computers. Were you using a slide rule for your maths and?
Not quite, but interestingly, in the cockpit, we're using spring balances and tape measures to measure stick displacements and stick forces.
Okay, all right.
And an e-pad with a little with a test card on it, and so you'd actually take some measurements and then write it all down. So you come back and prepare your reports off those test cards.
Haven't we come a long way? The main elements after that, the main elements, and what the bits that kept you on the edge of your seat.
Well, they then once you do a certain amount of mathematics and physics and get a bit of a comprehension of how an aeroplane is designed, basically, they then start you in, lead you up into exercises, flying exercises. So you can actually go and apply some test techniques, and there are different test techniques for to measure certain aircraft parameters and characteristics. So they give you briefs on all those different techniques that you can use, and then they give you some exercises to go and try those techniques out. And again, everything's done incrementally. So you start off in the jet provost, for example, with a simple thing called a cockpit assessment, and that's really looking at how the man-machine interfaces. Things like how the displays are laid out, how the controls work within the cockpit. For example, if you're rolling hard, does your knee get in the way? Your thigh get in the way of the stick, for example, or the yoke if you've got a yoke? Can you access all the important instruments in quick, intuitive time, or and are they readable? Can you interpret them very easily? That sort of stuff. So that's fundamental.
Right.
And then you step from there into flight control system characteristics, and most pilots won't appreciate it, but there are characteristics in a control circuit, particularly with mechanical control systems, things like friction and breakout force that really have a big influence on how the aeroplane flies. If you've got big breakout forces, for example, when you're trying to roll an aeroplane, what happens is you tend to have to apply more force than is required to achieve the roll rate. So you'll always over control. So that's how a breakout force can affect a
So how do you change a breakout force?
You do that through sometimes through maintenance and just using lubricants, or you do it through all the way the flight control system is designed. So there are no step inputs anywhere within the control system. In other words, it's all the pulleys and angles involved are curved or smooth, so there's no step inputs anywhere in the system. So if there is a breakout force, that's then you go and look at it and say, well, where is that force coming from?
Yeah.
And then if there is a fix available, then you go and design a fix and go and check it again. I think we went from there into performance handling, and we do that on both on the Canberra bomber and also on the HS748. Not performance handling, performance measurement. Again, so this is all incremental, a step up. So now this is just simply a matter of flying fairly precise altitudes and speeds and measuring fuel flows and those sorts of things. And out of that, you develop a graph on how quickly an aircraft can climb at different speeds, how quickly it can descend, and you work out approach speeds, stall speeds, that sort of thing. I should say probably before we got into that, we would have done stalling, and I can't recall what we did that in, but I think I did it. Yeah, I can't recall. But anyway,
so just on stalling to make sure people understand what you mean by stalling.
Okay. When we say stalling, we're not talking about engine stalling. We're talking about aerodynamic stalling. And what that means is when you slow an aircraft down to a certain point, the airflow over the wing breaks down and you lose your lift. So the aeroplane will then hopefully pitch nose down and try and recover, get some speed back so you get back to flying speed where you're getting some lift out of the wing.
What else might it do?
Some aircraft have a nasty tendency to yaw as they stall, and that can then bloody lead to a spin.
Right.
Now, the spinning exercise is one of the last exercises we do on the course because that's the most dynamic and it's probably the most risky. But it was the one I enjoyed most, actually, would you believe? All the rest I found a bit mundane. In fact, the chief test pilot said to me, or the chief instructor said, when I did my spinner report, he said, "What happened to you, Hacky? Did a light bulb come on in your head?" Because eventually I wrote a reasonable report, I gather. Up to then, I was struggling with my report writing. And that's the other aim of the course, is to teach you how to convey your observations and your measurements to an engineering audience that can understand them. So you need that.
So do you get to the stage then where you fly an aeroplane that you have never flown before, you do not know what speed the stall's at, you don't know much about it at all, and maybe simulating sort of an experimental aeroplane, do you get to that stage where you've got that challenge to fly an aeroplane that you really haven't got a flight manual on?
Yeah, well, that's the culmination of the course. They send you off to an aeroplane you haven't flown on the course, or one that you haven't flown in your career. And you're given 10 flight hours, normally with a team of two. So you both share the flying, 5 hours each. And out of that, it's called the preview. And out of that, you've developed a report on that craft in a particular role. Depends on the class of the aeroplane you're flying. I did mine on the NAT, which is a trainer. And the role we were assessing against was an advanced trainer role. So that was quite interesting. And that itself is an interesting little aeroplane. It's you can sort of step over the windowsill into the cockpit and step out again. So it's a sort of machine you'd wrap it up under your arm and take it home each night, almost.
Yeah. So when you say then you wrote a report after 10 hours,
yep.
what are you talking about? Something a flight manual size, or a book, an
Uh,
assessment?
well, it's probably about, depending on the aeroplane and the complexity of the machine, but it's probably an inch thick.
Let's talk about the nap. So about an
Yeah,
inch.
and that. Yeah. Well, by the time we had diagrams and
Yeah.
performance graphs and some images to give people an idea of the craft, comes to about probably in our case, in the Nats case, probably 3/4 inch thick.
Okay. So
So,
now you've are there other highlights of the test pilot's course you want to cover before I ask you another major question?
well, probably the other thing after we did the first initial 5 aeroplanes, they sent us off to fly the Jaguar, which was a brand new machine in those days when I did the course.
What did it do
And
for a living?
it was it was a light attack aircraft. It was designed actually as an advanced trainer, but it was probably far more capable than that. So they turned it into an advanced light attack aircraft, and it was a very early integrated navigation weapons aiming system in those days. So it was great to get into a machine that was more modern or leading in the modern direction. Um, Up to that stage, everything else is clockwork, like Mirage, Jaguar. Oh, sorry, not Jaguar. Hunter, Canberra. They're all old analog displays and big needles, whereas
Yeah.
the Jaguar
Yeah.
had a display and had a movie map display, and you could load latitudes and longitudes in the nav system,
Oh,
and had some weapons capabilities as well as a stores management system. So that was good.
would be.
Probably a little funny thing. We flew the simulator, the Jaguar simulator, and unfortunately, we were all a bit ham-fisted. We used to actually crash it occasionally. But in those days, simulators with a visual system were designed to fly over a model, uh, a paper model of the Earth. In other words, for hills and trees
Yeah.
and sheep and all sorts of stuff on it. And if we crashed this, and the imagery was given by a set of cameras that tracked your position over the terrain
Oh,
on a gantry system, up and down, left and right. And if you crash this jolly simulator in the vertical quite severely, the camera would go through the Earth model, and
oh,
that should be a hole in it. And people weren't too impressed with that.
I bet you
So,
weren't too popular.
yeah, so that
Particularly
no,
when
that
it
was
was about to get when they were about to go home and have dinner.
yeah, exactly. All the TPS students weren't very popular up that simulator facility at all.
So when you finished that course, that you got a posting back to where?
Back to RJU, the flight test
What
unit,
what's Ardu?
aircraft research and development unit.
Okay, and so that's when you start to become of value to the Australian aircraft we're flying,
Yeah, that's
and
when you start to do some work. Typically in Australia, we didn't do any experimental flying as such. It's mostly what I call developmental work, and a lot of my work was a wee bit of systems integration, like putting a new attitude indicator into a standby attitude indicator into the Mackie, um, and you just got to put that through its paces and make sure it doesn't topple and it actually displays correct attitudes, things like that. Um, we did a bunch of performance work. I did quite a bit of work on the Nomad in performance, single engine performance in particular. And I did a lot of weapons work with Mirage and F-111. I didn't fly the F-111. I managed the projects and got all the stuff together so we can go and drop the weapons off the thing appropriately.
so did the course where was the course, the test pilot course again?
UK, Boscombe
You
down.
Boscombe down, yeah. So did you find when you actually came back and started operating practically that course had been of value, or was it, or was a lot of it just a window dressing?
No, I felt the ETPS course in particular was very valuable for us at
Okay,
our stage of maturity, if you like, or
okay,
evolution, because we dealt mostly with analog aeroplanes, and we had mostly analog aeroplanes in Australia at the time. So, and we touched on a wee bit of digital stuff with the Jaguar and a few other simulators we went and flew,
Yeah.
but so we had an exposure to that, but we hadn't had any real experience with it.
So what was the latest? What was the most modern Australian military aircraft you've operated with?
The most modern one was the F-18 Classic. Yeah,
What
so
sort of work did you do with that?
I did mostly production flying with the F-8. Oh, not quite true. I did a lot of production flying, and then eventually I went back to the flight test unit and did a lot of weapons work and some systems integration work and some performance work.
Can you give us an idea of what you had to do, say, on a weapons test? Because I know during that time, say, Mirages, F-18s, different weapons came into the Air Force's life. What would be involved in validating a weapon, say, a new weapon for an F-18 or a new weapon for a Mirage? Can you give us one that you might have validated, and what aircraft did you validate it for?
Yeah, well, I did. Trying to remember back now. It's a long time ago, Ringo. um,
And you still look like a youth.
I did a lot. I did some LGB. Australia was very early with laser guided bombs. I
Yeah.
think we're advanced to the Americans, in fact. So I did a bunch of LGB work off the F-11. As I said, I didn't fly the machine, but I managed the project. I did a bunch off the Mirage, also Coringa, which is an Australian designed cluster weapon, which never went to production because it was that sort of weapons basically outlawed by Geneva Convention because they're a nasty piece of kit.
So can you just cover the LGB for a minute?
What you do typically you do two flights initially, which are captive carriage flights. So you'll take the weapon out to you just go through again incrementally. Everything in test flying you do incrementally. You don't leap off the edge rapidly because you never know what the edge is. So you take it out and put it, do some maneuvers, reasonable maneuvers at a reasonable speed, and then accelerate out to another speed, do the same maneuvers again, then eventually take it out to the max speed you're designing or you want the capability to achieve. And we always go a bit beyond the limit condition, just so we know there's no cliff edges. So that'll be the first two flights. One is just the handling qualities flight, and the second one is what we call a shake, rattle, and roll, where you just take it out and expose it to maximum speed for as long as possible. And that's really just to demonstrate the durability of the weapon because, kinetic heating, when you're doing 630 knots, the weapons get hot, fusing gets hot, electronics get hot, all that sort of stuff, and things vibrate. So when you expose them to that sort of speed for a long time, they can break in various ways. So that's what that flight's all about. Then after that, you then step through an envelope to prove the release envelope. And again, you'll start off at what you think is some benign point, typically around the 10,000 foot mark at a probably 300 knot sort of speed with a fighter type aircraft. The reason you choose that might sound a bit fast, but by being medium altitude, medium speed, it gives you time if something goes wrong. You can imagine if you start off really slow, and say even a medium altitude, if something goes wrong, you've got nowhere to go but downhill. You've taken one time factor out of the equation. So having a bit of speed, having a bit of altitude allows you to recover from a situation if you have to.
Does that mean you also then tested if the aircraft had developed any vices with these weapons loaded at slow speed, at approach speed, and manoeuvring at low speed?
Well, unfortunately, like all this stuff, you gotta take off. So you got to expose the weapon configurations through that low speed range anyway. But at that stage, you're always accelerating. So that's a risk you take. If there was prior to actually going flying these things, you'll have some wind tunnel knowledge probably.
Yeah.
How it should handle, and also with a bit of experience, you realise that until you get to about 250 knots, external weapons on an aeroplane, a fighter class aeroplane, aren't going to have much effect on the aeroplane.
Okay, all right.
So you can be fairly comfortable that nothing untoward is going to happen while you're accelerating to a reasonable speed.
What was the next step? Was it testing its operational use?
We at RG didn't do any of that stuff. Once we cleared the carriage and release envelope, went off to the squadrons, and they then actually trained with the weapon, and they then evaluated its operational effect.
So how did you test its release
That's the next.
in the sense of flying along and you let the weapon fire or go or launch? Did that need to be tested, its effect on maybe on the engine or?
Yeah, depending on the weapon. With forward-firing missiles, of course, there's a risk of the missile efflux upsetting the engine, airflow through the engine. I'll come to that in a minute. But with LGBs, for example, they're released from under the wings, so off stations. And as a lot of people don't realise, they're actually explosively jettisoned. Because once you get up to around the 450, 500 knot mark, the flow field around the wing of the aeroplane is very powerful. And if you don't actually force the weapons away from the wing, they can actually get hung up and bounce around under the wing until you get out of the way and they disappear. But so they're actually, they have in the pylon the weapons are attached to, there are two little bloody pistons that are fired with explosives, and they push the weapon away and get us through the flow field, so it separates from the aeroplane cleanly, hopefully. And one of the issues is the airflow around the weapon, because they're an aerodynamic shape, can actually generate forward lift on the weapon, and they can pitch nose up. So there's some effort goes into designing the amount of explosive force you apply to each of the ejectors forward and aft to make sure you generate a little bit of a nose down pitch on the weapon, so it won't pitch back up into the wing while it's still in the flow field.
So did you ever have any incidents that were a bit dangerous with that sort of weapon release?
No, I didn't. No, all our stuff, LGBs and big weapons, were pretty benign, basically, from what I know. Nothing dangerous. We did some work with the F-11 trying to drop a high drag Mark 84, which is a 2,000-pound bomb, and using a parachute high drag device. And it sort of came with a manufacturer recommendation, only 430 knots maximum release condition. And we thought at the time, we're thinking, well, if this is a high drag weapon, so you're going to fly the target and drop it. And at 430 knots, you're going to be very vulnerable.
Mm.
So we try to get it out to about 550 knots release condition. And that was interesting because the first couple we dropped, we stepped out in increments. And the first couple we dropped, they survived quite happily. And then we went out, I think, to about 520 odd knots, and then one of the tails failed. So then we started to work back again, and guess where we settled? 430 knots.
Oh, no. So the weapon was actually limiting the aeroplane.
Yeah, limiting the operation, absolutely. Yeah. I don't think we ever actually went ahead and bought those weapons. I can't recall. But the other thing I wanted to mention, in one of the charts there I've got, is the IS MAC chart. As I said, we do everything incrementally. And I need to talk a bit about speed here. The aeroplane's controllability and the way the forces on the aeroplane are generated by what we call dynamic pressure, which is indicated airspeed effectively. But then when you're talking about aircraft stability, you need to be talking about its true airspeed. That is the inertia of the craft. So your controllability is given to you by indicated airspeed, but the actual stability is affected by true airspeed, which is inertia. And so what we used to do, we start off, let's take a speed here, say 300 knots, for example. We start off, say, as I said, at 10,000 feet, 300 knots. and you'll see that's about Mach 0.7. So then from there, you probably step up the 300 knot line, or no, the Mach 0.7 line, and you go to say the 200 knot point. So you've actually kept the inertia the same, but you reduce your controllability. Does that make sense?
Yeah.
Because you're now 100 knots slower, but your inertia is the same as it was at 10,000 feet. So you step up and go to that point and do a release at that point. Then you might step out to say Mach 0.7 and come back down in this graph to say 350 knots, which is 10,000 feet. So again, now you've kept the inertia the same, but now you've increased the controllability by going to another 50 knots faster.
Right.
So that's how you step around an envelope. And, we were working envelopes sometimes out to Mach 1.2 and out to 650 knots. So you can imagine you've got to be a bit careful when you get those sorts of energy states, how you actually step around that envelope, both from a controllability point of view and a stability point of view. So that's how we use that chart. And obviously, modern aeroplane, modern developmental organisation will have software to do all that stuff. But in my day, we're doing it mandrolically. Yeah. So that's how you actually develop an envelope for a weapon off an aeroplane. And it can be quite complex. You've got army systems as well. You've got to actually prove that they actually will work throughout the flight envelope that you choose. And you have both on the older weapons, you had both nose and tail fusing. Sometimes they're mechanically armed, sometimes electronically armed. So there's quite a few parameters there that you've got to actually bring together into a matrix of test points to make sure you don't actually give an envelope that is not actually going to function properly, either because the fuse doesn't work or because hydrate tail fails or because the weapon doesn't separate cleanly, and its trajectory, its aerodynamic trajectory is just all over the shop. It's too variable.
So was it satisfying flying?
I enjoyed it. I'm not the sort of guy who flies for the sake of flying. If I've got a job to do, I love flying and I love doing that job. So yeah, and it requires precision. You got to actually try and hit the parameters very precisely if you can. And remember, we're doing this stuff in dives and tosses, and trying to hit the actual speed, altitude, and conditions that you're looking for at release is quite a challenge. So that was always satisfying when you did it. You felt like you achieved something for the day.
So how would you, just getting towards the end of this, life as a squadron pilot, and then life as a test pilot? So if you had your life as a squadron pilot, let's say on the F-18, and your life as a test pilot for the F-18, how did they interface with you as far as what you joined the Air Force for?
It's a long story, but
well, keep it brief.
Yeah, and some people think this is a bit strange, but before I left the Mirage to go on test pilot's course, occasionally we go and do what we call a general flying exercise by ourselves.
Yeah.
And I used to find those quite boring, even though you could go out and do some low flying, go supersonic, do some aerobatics. And I used to find after a while I've done a loop 3 times in the last week and I'm not getting better. So so the one thing about test flying was you always had something to do. You seldom flew without something to do for a purpose. So that was challenging and that was actually good. Always working with a team. In most of the stuff I do, I was working with a bunch of gunnies and we used to take the aeroplane away, deploy away to Woomera and places like that. And you're actually working by yourself to a large extent because you don't have all the support you might have from a base. So you got to use your use your jolly initiative occasionally.
So if you were now having a beer with a flight lieutenant who was contemplating applying for test pilots course, what would your wisdom tell him or her? What would
I'll
your
tell you,
wisdom? There's plenty of, I should tell you on that, there are many women pilots in the Air Force, and they're all doing a fabulous job. So sometimes my terminology is comes through old age. But there's some F-35s that at Williamstown right now, flown by some excellent pilots, women, and they're doing a top job. So I just wanted to say that. But anyway, what would you tell a pilot who was thinking about doing a test pilots course and in reflecting upon how they're now a squadron pilot and they might be contemplating becoming a test pilot? What would your wisdom say? How might you counsel them?
well, I'd advise them to jump at it because it's a fantastic course. It's multinational. Um, it gives you another facet to your whole professional piloting career. The only problem with it is once you get involved in the test flying game and you stay in it for a while, your promotional prospects are diminished. So if you want to make Chief of the Air Force, probably not a good move. Um, if you're happy to just to do some really good flying and have another experience in the flying world, then I'd say go for it.
Good.
Well, yeah, I hope that gives you a bit of an overview of the game. But I didn't actually talk about the F-18 flying, but most of that was out of the factory at Avalon. So although I did some work in the US with both our first two-seaters over there and also with the early prototype aeroplanes. And probably one of the more challenging things I did over there was one of the tasks I got was to release a nine 1,000-pound weapons from an aeroplane in a 60-degree dive at Mach 1.3.
Wow.
In salvo mode. So tossing away 4.5 tons of weapons
Wow.
in a 60-degree dive at Mach 1.3, it was pretty well. It was all over in a flash, of course, but yeah, try and hit those parameters is a bit of a trick in itself. So that was one of the things. But also I got to I'm talking about 1984 now, so I got to fly a voice control system in the F-18. And this is very early voice recognition days, and I flew it eventually in a two-seat aeroplane with another Aussie in the back seat, engineer. He flew the mission actually. It was a low-level mission right around Southeast USA, and he flew the mission. I was just in the front watching for birds and power lines, and he was a bit of a tart. Cole White's his name, and he was in the back trying to talk to this machine and get it to tell him his fuel state and his weapons load and load navigation latitudes and longitudes and things like that. But that was an interesting exercise. As I said, very early voice recognition days and not very successful.
Wow.
Now, Ringo, I should give a little rap for Cole White. He's an engineer, an Aussie engineer, flight test engineer, and he's a real aviation tart. So much so that he spent a couple of years in the US at Patuxent River, and he flew in US airplanes the whole time he was there, F-14s, A4s, F4s, you name it. So much so that eventually the US Navy awarded him a set of aviator wings officially. So he's very proud of that. Anyway, he's also a bit of a character. But anyway, so that was our sort of almost my final episode in the US. But I did do, as you're about to mention there, I was involved in a dynamic departure of an F-18. It was a two-seat aeroplane. I was only in the back seat as a sandbag, so I didn't have much to do with it. But
well, you did. You had a lot to do with it.
The aeroplane came off the assembly line with a bit of a roll-off problem at 20 degrees angle of attack, and McDonnell Douglas couldn't solve the problem.
The roll-off problem.
Well, at 20 degrees angle attack used to roll, I think, to the right, and that was a bit unusual. Um, most other airplanes didn't display that sort of characteristics. All other airplanes didn't. So McDonnell Douglas tried to solve the problem, and they couldn't really work it out. So they passed the airplane onto the US Navy, and it was over at Pax River while I was there with 101 and 102, our first two-seaters. And I swapped a ride in the back of this thing for a ride. They wanted to have a ride in one of ours to see if it had the same problem. So I was in the back seat of this particular aeroplane for the last flight in the series of tests they were doing, and they'd loaded it with maximum mass asymmetry load. So they had two 1,000-pound bombs on an outboard wing station, nothing on any other stations. So 22,000 foot-pounds of lateral mass load, asymmetry load, centerline fuel tank, wingtip missiles, and all of those things make the two-seat Hornet, which is weak directionally stability-wise anyway. They made it even less stable directionally, and they're going through a series of wind-up turns. A wind-up turn is simply a manoeuvre you use to maintain a speed, and then while you do some rolling or pitching manoeuvres at the same time. So this flight, the departure flight, was Mach 0.9, and we started at 30,000 feet, and a right-hand turn to pull the 20 alpha, 20 degrees angle of attack, which is about 6 and a bit G. And once we got there, we applied full right R on control, and full left R on control. I'm sorry. And the airplane rolled through about 30 degrees of bank to the left, and then it went like a frisbee to the right. So obviously we'd stalled the fins and lost all directional stability. So it was all very dynamic initially for about the first 2 or 3 seconds or less. We went from Mach 0.9 to almost zero speed in the forward direction almost instantly, and pulled about 6G laterally. I saw the guy in the front seat. I saw his head bounce on the canopy both sides. And after the initial dynamic departure, which you missed there in the video because it was obscured by the cloud, but the aeroplane settled down, upside down, rotating to the right, quite smooth. So it was all a bit of a non-event, really, once the dynamics of it had passed. So that's the right roll to the right, pulling to 20 alpha. In there somewhere, apply left stick. It goes like a frisbee. You see the puffs of smoke out of the tailpipes there.
Coming again?
Yep. That was the engines, both engines flamed out. They're in full burner. That's the engines flaming out. Anyway, okay. once it spent all its energy, I thought both fins had separated because of the dynamics of the departure and the fact it was so smooth once we were upside down. I thought, well, we're just going to continue going like this all the way into Chesapeake Bay. So I found the bloody seat pan handle, and I was thinking to myself, well, I could eject, but I had command ejection in the back seat as well. And I thought, I better check my altitude. I had no displays apart from the standby, which was down between my knees on the center console behind the stick, and the little standby altimeter, which is only about 2 inches in diameter, was showing 18,000 feet still. So I thought I could wait a while longer. And about that stage, it popped nose high and went like a dart. So both the guy in the front and I were on the stick trying to recover from the dive. Anyway, his communications hose or line had disconnected, and so I couldn't talk to him. So I thought he was unconscious. That's why I was on the stick trying to recover. But he eventually got himself connected again and said, I got control, and took over and came and landed. But everything was still in the aeroplane, the weapons, the tank, the fins, of course. But the whole thing took about 18 seconds, and we went from 30,000 feet to 12,000 feet by the time we bottomed out.
Good end point, Ron. Thank you very, very much, mate. And we'll wind it up on that very high note. Catch you later.
Okay, see you. There we go. Thanks.
If you enjoyed this chat, could you please subscribe to our channel? It would help us a lot. Also, could you have a look in the description of this particular video and look for Australian Military Aviation Historical Association or Air Force Association New South Wales or Wings magazine. All these organisations you can either subscribe or register with if it takes your interest. They are all organisations that support veterans, all run by volunteers, and all are not for profits. Thanks.